The situation involves a wastewater treatment plant with 3 utility services, 3 generators, and 5 pieces of power distribution switchgear, all operating at 480 volts. There are no 277-volt loads, and no neutrals have been installed in the building feeders, only equipment grounds. The design bonds the generator neutrals at the first overcurrent device. 3-phase conductors and an equipment ground are installed from the generator switchgear to each of the utility service switchgears. Each utility service switchgear has a service entrance rated circuit breaker, and the utility neutral is bonded to this location. Transfer between utility and generator is accomplished via circuit breakers for 2 of the utility services and via 3-pole automatic transfer switch at one of the switchgear. The electrical inspector is requiring 5 conductors, specifically 3-phase conductors, 1 grounded neutral conductor, and 1 equipment ground conductor, from the generator switchgear to each of the utility service switchgears. The inspector's reasoning is that the generator and utility neutrals are connected together via the equipment grounds due to the main bonding jumper at each utility service switchgear. The NEC addresses the scenario specifically through the concept of separately derived systems, or SDS. A generator, when operated in isolation from the utility supply, qualifies as an SDS. Section 250.30. 8.1 of the NEC dictates the grounding requirements for SDS. This section mandates that the neutral of an SDS must be bonded to the equipment grounding conductor at the first point of connection to the premises wiring system or the first overcurrent device. This establishes a local ground reference for the generator system, ensuring proper operation of overcurrent protection devices and minimizing the potential for voltage imbalances. The critical point is that by bonding the generator neutral at the first overcurrent device, the design already complies with the NEC requirements for grounding an SDS. The inspector's concern about the generator and utility neutrals being connected via the equipment grounds is a misunderstanding of the function of the equipment grounding system. The equipment grounding system is designed to provide a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protection devices. The main bonding jumper at each utility service switchgear connects the utility neutral to the equipment grounding system, establishing a common ground reference for the entire system. However, this connection does not create a parallel neutral path between the generator and utility sources. The current from the generator neutral does not flow through the equipment grounding system under normal operating conditions. The equipment grounding system only carries fault current during a ground fault event. Therefore, requiring an additional neutral conductor from the generator switchgear to each utility service switchgear is unnecessary and not in accordance with the NEC. The design, by bonding the generator neutral at the first overcurrent device and providing a dedicated equipment grounding conductor, already ensures a safe and compliant installation. Consider the impact of adding a neutral conductor from the generator to each utility service entrance. Firstly, this would create multiple neutral to ground bonds in the system, which is a violation of NEC section 250.6. Multiple neutral to ground bonds can lead to circulating currents in the grounding system, increasing the risk of electrical noise and potentially creating a shock hazard. Secondly, adding a neutral conductor would not improve the performance of the overcurrent protection system. The equipment grounding conductor already provides a low impedance path for fault current, ensuring that overcurrent devices operate quickly and effectively. Thirdly, the additional neutral conductor would increase the complexity and cost of the installation without providing any tangible benefits. The NEC is based on fundamental principles of electrical safety and grounding. These principles are designed to protect people and property from electrical hazards. The NEC is not intended to be a rigid set of rules that must be followed without regard to the specific circumstances of each installation. The electrical inspector should be knowledgeable about these principles and should be willing to work with electrical engineers to ensure that installations are safe and compliant. In this case, the electrical inspector's interpretation of the NEC is incorrect and would lead to an unnecessary and potentially unsafe installation. The design, as it stands, complies with the NEC requirements for grounding an SDS and provides a safe and reliable electrical system for the wastewater treatment plant. To further clarify the situation, consider the following points. 1. The generator is operating as an SDS when it is providing power to the loads independent of the utility. 2. The utility service is the source of power and the neutral is bonded at the service entrance. 3. The equipment grounding system provides a path for fault current to return to the source, whether that source is the generator or the utility. 4. The generator neutral is bonded at the first overcurrent device, establishing a local ground reference for the generator system. 5. The equipment grounding conductor connects the generator switchgear to the utility service switchgear, providing a low impedance path for fault current. 6. The main bonding jumper at each utility service switchgear connects the utility neutral to the equipment grounding system, establishing a common ground reference for the entire system. 7. Adding a neutral conductor from the generator switchgear to each utility service switchgear would create multiple neutral to ground bonds in the system, which is a violation of the NEC. In summary, the electrical inspector's interpretation is not in accordance with the NEC. The design, by bonding the generator neutral at the first overcurrent device and providing a dedicated equipment grounding conductor, already ensures a safe and compliant installation. It is important to communicate these principles clearly and concisely to the electrical inspector to resolve the issue.